everyone, welcome back to my YouTube channel. So for this week, I'm going to explain to you how you should answer test 1 questions. So altogether, we have 6 different questions from 3 different chapters, chapter 1, 2 and chapter 3. So let's get started with the first question. Question number 1A. Reaction between 22 grams of calcium carbonate and 4 moles of hydrochloric acid shall produce carbon dioxide and 2 other products. Calculate the volume of carbon dioxide that shall be produced if the reaction was conducted at STP. In order for you to answer this question, you should be able to write a balance equation for this reaction. So in this reaction, you have calcium carbonate which will react with hydrochloric acid, which will produce carbon dioxide and 2 other products. So let's write this information first. So you have your calcium carbonate. You will react it with hydrochloric acid, which shall produce carbon dioxide and 2 other products. In order for you to predict what is this product, the easiest way is to write the ionic form of the reactant. So you have Ca, which is Ca2+, and your CO3 is CO3 2 minus, H is H plus, and Cl is Cl minus. Alright, so what we are going to do now is we are going to swap in between the positive and negative between both the reactant. So the first one, Ca positive, must react with something negative from the other reactant, and you're left with CO3 negative, so it will react with something positive from the other reactant. Okay, so from the first one, make sure that you always write the positive first, right? So you have your Ca, and then it react with your Cl from HCl, so CaCl. Then you look at the charge, Ca is 2 plus and Cl is just negative, so you need more Cl in order for you to balance out the charge. So you have CaCl2. Done. And then the other part is CO3 and also the H. So we are going to write the positive one first. So you have H and then you have the CO3. Your CO3 is 2 minus and your hydrogen is just plus. So it means that you need to have 2 over here. But in the question, it states that one of the product is carbon dioxide. So in between this product and this product, only this part can produce the carbon dioxide because there's no O here, there's no oxygen in the CaCl2. So in saying that, we can write the one of the product for this reaction is actually CaCl2. Alright, next up we are going to look upon the H2CO3. Alright, from here we are going to take away CO2 because given in the question states that one of the product is actually CO2. So once you have taken out your CO2, what you have left here is just H2O. So from there we can say that the other product shall be H2O. Okay, but this is not a balanced equation just yet, so we need to balance out this equation. Alright, so as we have discussed just now, calcium carbonate shall react with hydrochloric acid to produce carbon dioxide as stated in the question, plus water and also calcium chloride. Okay, so the next up, we need to try to balance out this equation. So the first obvious thing that we have here is your hydrogen. So you have 2 hydrogen here in the equation at the product. So it means that at your reactant you need to put 2. So let's check on your chlorine. So 2 times 1 is 2. You have 2 chlorine here. And how many calcium that you have? You have 1 over here and you have 1 over here. So the next up is your carbon. So you have 1 carbon here and 1 carbon here. And the total number of oxygen that you have is 3 at the reactant. So we have 2 here and another 1 here. So you have 3 oxygen. So this is your balance equation for this reaction. Let us now move on to the rest of the question. Given to you is 20 grams of calcium carbonate. So when the mass is given to you, it means that you are able to calculate the number of mole. So the number of mole for your calcium carbonate is equivalent to the mass over RMM. The mass is given to you, which is 22 grams, and your RMM is, so for your calcium is 40.078, and for your carbon is 12.011, and for your oxygen is 3 times, because you have 3 here, 15.9994. So you will get the mole of your calcium carbonate is actually equivalent to 0.2198 mole. From the equation, we can know that 1 mole of CaCO3 will need 2 mole of HCl. So from the calculation, we have this much of CaCO3. So 1 mole of CaCO3 shall need 2 mole of HCl. Since we only have 0.2198 mole of CaCO3, therefore the number of mole for HCl that we need is 2 times 0.2198, which is equivalent to 0.4396 mole of HCl. Right, why is this important? Because we need to determine which one of these reactant are the limiting reagent. So if we look back at the question, you actually have 4 moles of hydrochloric acid. So we can conclude that this is the excess reagent. So whatever product that is going to be formed is going to reflect on this amount of calcium carbonate. Since we already decided that the calcium carbonate is the limiting reagent, so this shall dominate whatever amount of carbon dioxide that shall be produced. So in saying that, 1 mole of calcium carbonate shall produce 1 mole of CO2. So from the calculation just now, the number of mole for calcium carbonate is 0.2198 mole of calcium carbonate. So the amount of carbon dioxide that is going to be produced is the same, which is 0.2198 mole of carbon dioxide, right? And then in the question, you were asked to calculate the volume of carbon dioxide when the reaction is conducted at STP. So since it is conducted at STP, so the pressure is 1 atm and the temperature is 273 Kelvin. So what we are going to use is the ideal gas law formula, which is PV equivalent to nRT. So the pressure is 1, volume is the one that you're going to calculate, N is this 0.2198, R is 0.0821, and your temperature at STP is 273. So your V is equivalent to 4.9264 liter. So this is the final answer for the first question, question 1a. Let's move on to question 1b. A mixture of helium, hydrogen and carbon dioxide gases are at pressure of 1200 torr in a 4-liter closed container. There are a total of 24 moles of gas molecule in the container. If the helium concentration is 2 mole per liter and hydrogen concentration is 1.5 mole per liter, estimate the partial pressure of carbon dioxide in atm. From the question, we know that the volume of the container is 4 liter and the concentration of helium and also hydrogen is 2 mole per liter and 1.5 mole per liter respectively. Since the volume of the container is 4 liter and the helium is 2 mole per liter, so for every liter, 1 liter, they will have 2 mole of helium. So since we have 4 liter, so 2 divided by 1 times 4 is equivalent to 8 mole of helium. Same drill with the hydrogen. So for every liter, it have 1.5 mole of hydrogen. So we have 4 liter, so 1.5 times 4, you should get 6 mole of hydrogen. In the question, it states that a total of 24 mole of gases, right? So you shall have your helium plus hydrogen plus carbon dioxide. The total shall be 24. So in order for you to find what is the number of mole for carbon dioxide, it is 24 minus 8 minus 6. So that will be equivalent to 24 minus 14. So it's equivalent to 10 mole of carbon dioxide. Okay, so we know that the number of mole for carbon dioxide is 10 mole, and then we also know that the total pressure is 1200 torr, but you were asked to calculate in atm, so we are going to convert this unit first. So 1200 torr, we are going to convert it to atm is 1/760 times 1200, so you shall get 1.5789 atm, right? You were asked to estimate the partial pressure, so the partial pressure is actually mole fraction times the total pressure. So now we are going to calculate the mole fraction. What is the mole fraction? So the mole fraction of carbon dioxide is equivalent to the number of mole for carbon dioxide divided by the total number of moles. So the total number of mole is 24 times your total pressure, which is this one, 1.5789. So it is equivalent to 0.6597. So this is the partial pressure for your carbon dioxide. Now let's move on to question number 2a. Given the enthalpy value for the following reaction are as follows, manipulate the reaction above to determine the enthalpy change for those equations. Alright, let's look at the equation one by one together. So we are going to start with the first one. So the first equation, we are looking at the Al here. So we do have Al at the reactant, and indeed it is 2. And we have another one which is the AlCl3, and we do have 2 AlCl3. Only that here is solid and this one is aqueous, but that's okay. So we are going to accept this equation as it is. Now we are looking at equation 2, which have hydrochloric acid, which have nothing to do with the target equation. So we are just going to keep this aside for a moment. and moving on to equation 3. So in equation 3, what we are looking at is your chlorine. So indeed the chlorine is at the reactant, but we need 3 chlorines all together. So what we are going to do is that we are going to times 3 on every part of this, right? And up next is the fourth equation. So we have AlCl3 on both sides, but what we are going to do is we are going to look at the amount of AlCl3 that we need. So we do need 2, so we are going to times 2. And then if you look at here, you really need a solid AlCl3 at the product. So what we are going to do is that we are going to switch this up, right? Once we switch this, means that this negative will turn into positive. So we are coming back to the second equation here. So we have HCl. One is in gaseous form and the other one is in aqueous form. So we do not need the HCl at all in the reaction, but if you can see here in your equation 3, you do have HCl lingering around, but since we are going to times 3 here, means that your HCl is actually equivalent to 6. So what we are going to do now around here, we are going to times everything with 6, right? I think that's about it. So we are just going to copy back everything here so that we can look at it properly and we'll see how it goes. So now what we are going to do is we're going to copy back all these equations so that it's easier for us to see. So the first equation, we have 2Al in solid form plus 6 HCl in aqueous. You will produce 2AlCl3 in aqueous and also 3H2 in gaseous form. Your delta H will be equivalent to negative 1049 kilojoule. The next one is the second equation, so you're going to times 6 to everything. So 6 HCl in gas will produce 6 HCl in aqueous, whereby your delta H should be equivalent to negative 448.8 kilojoule. Right, and then we are going to do equation 3, which you times 3 to everything. So 3H2 in gas plus 3Cl2 in gas as well will produce 6 HCl in gas, whereby your delta H should be equivalent to negative 555 kilojoule. And the last equation, which is equation number 4, you're going to switch it up. So AlCl3 in aqueous form, but you have already times 2, so we'll produce 2AlCl3 in solid form, and your delta H should be equivalent to positive, because you switch it up, so positive 646 kilojoule. Right, now what we are going to do is we are going to look at the similar things at the reactant and the product so that we can slash it out, so that we will remove it to match our target equation. So the first one that we want to slash out is the HCl. In the reactant we have aqueous HCl, and at the product we do have aqueous HCl as well. And in the reactant we have gas HCl, and we have another one in the product around here. So what else that we do not need is the AlCl3 which is in aqueous form. So we have two AlCl3 in aqueous form here, and we do have another one around there. So we do not need hydrogen gas, so we have hydrogen gas at the product and also one at the reactant. So now we are left with 2Al plus 3Cl2, which shall produce, so this one Al is in solid, this one is in gas, and 2AlCl3 in solid, right? So which matches exactly as our target equation. So what we are going to do with this delta H is that we are just going to do the summation of this, and you should get your delta H is equivalent to negative 1406.8 kilojoule. So this is the final answer for question number 2A. Question number 2B. In one experiment, 25 grams of sample of an alloy was heated to a certain temperature. The heated alloy was then dropped into a beaker containing 90 grams of water at 25.32 degrees Celsius. The temperature of water rose to a final value of 27.18 degrees Celsius. Predict the final temperature that the alloy is being heated at the beginning of the experiment. Given that the heat capacity of water and alloy are 4.184 and 0.3847 joule per gram per degree Celsius respectively. Before we answer this question, I'm just going briefly on what is happening in this question. So you have this alloy and you go and heat this alloy up. Once this alloy is being heated up, it is being dropped in a container with water, 90 grams of water. So the initial temperature of the water is 25.32 degrees Celsius, and then once you already put this alloy inside here, and when equilibrium happens, so the temperature turns to 27.18 degrees Celsius. So in saying that, when we talk about water, the initial temperature is equivalent to 25.32 degrees Celsius, and the final temperature is equivalent to 27.18 degrees Celsius. But for the alloy, on the other hand, the initial temperature should be the temperature, the last temperature, just before it is being put inside the water. So the initial temperature we don't know, and the final temperature, because we assume that after a while equilibrium will be reached, so the final temperature shall be the same, which is 27.18 degrees Celsius. Right, so in this system is actually you have the water, and also you have the alloy. So remember the first law of thermodynamic, it should be constant, so it is equivalent to 0. So from here, then only we can start to do the calculation. So just like we have explained just now, so Q water plus Q alloy should be equivalent to 0. So Q equivalent to ms delta T, so plus ms delta T is equivalent to 0. So we are going to do the water first. So water, the mass is 90 gram. So 90 gram times the S, which is 4.184, times the changes of temperature, 27.18 minus 25.32. Please remember the changes of temperature is always final minus initial. So plus for the alloy, the mass is 25 gram and S is 0.3847 times the final temperature is 27.18 because we assume it is at equilibrium minus X, the initial temperature that we didn't know. So what we are going to do now is we are going to put the water on the other side so that it's easier for us to calculate. So I'm going to calculate this one first. So I get 9.6175 times the changes of temperature, so 27.18 minus X is actually equivalent to negative 7.0040 times 10 to the power of 2. Right, so what you're going to do is you're going to times each one of this, so you are going to get negative, because here is negative, right? Negative 9.6175 is equivalent to this value, negative 7.0040 times 10 to the power of 2, because this one you're going to move to the other side, so minus 2.6140 times 10 to the power of 2. Right, so this one should have X. Okay, so your X should be equivalent to this value, which is negative 9.6180 times 10 to the power of 2 divided by this value, so divided by negative 9.6175, hence you will get your X is equivalent to 100 degrees Celsius. So from the beginning we already heated the alloy up till 100 degrees Celsius, and then we put it inside the water, and when it reached the equilibrium the temperature dropped to 27.18 degrees Celsius. So the final answer for the question 2b is 100 degrees Celsius. Moving on to question 3a, the experiment observation are obtained for the following reaction. Calculate the rate constant for this reaction. Alright, the first thing that we need to do is we need to write the rate law. So rate is equivalent to concentration of A to the power of X, concentration of B to the power of Y, concentration of C to the power of Z. So now what we are going to do is we need to find the value of X, Y, and Z. So we are going to start with finding the value of X. In order for us to find the value of X, I'm going to use experiment number 2 and experiment number 1. So in saying that, we can say rate for experiment 2 divided by the rate experiment 1 is equivalent to K, concentration of A to the power of X, times concentration of B to the power of Y times concentration of C to the power of Z divided by the same thing. Alright, so what we are going to do now is we are going to plug in all the values that matches all of this. So in experiment 2, the rate is equivalent to 1.2 times 10 to the power of negative 3, and experiment 1 is 3.0 times 10 to the power of negative 4. So equivalent to K. Concentration of A for experiment 2 is 0.2 to the power of X. Concentration of B is 0.1 to the power of Y, and concentration of C is 0.1 to the power of Z. So we're going to do the same with experiment number 1. So concentration of A is 0.1 to the power of X, and the rest are 0.1 as well. Right. So the next thing we need to do is we need to slash out the identical thing. So K is identical and this concentration are identical. So from there we can say this one is equivalent to 4 is equivalent to 2 to the power of x. Alright, so what you need to do is you need to bring the x down. So x, we are going to make a ln to it. So x ln 2 is equivalent to ln 4. Therefore, your x is equivalent to ln 4 divided by ln 2. So x is equivalent to 2. So we are going to do the same drill for the y and also for the z. Alright, next up I'm going to find the value of y. So we are going to use experiment 3 and also experiment 1. So the rate is 3.0 times 10 to the power of negative 4 divided by the same value. So your k, and then the concentration of A is 0.1 to the power of x, then 0.3 to the power of y, and 0.1 to the power of z. So we are going to do the same for experiment 1. So 0.1 for every one of them. Right. So next up, we are going to slash out the things that are identical. So we have this one identical. So leaving u with 1 is equivalent to 3 to the power of y. So the same concept. So y ln 3 is equivalent to ln 1. So y is equivalent to ln 1 divided by ln 3, so you get your y is equivalent to 0. Right. Alright, the last one is the value of z. So for the value of z, we are going to use experiment 4 and also experiment 2. So the same drill, rate is 2.4 times 10 to the power of negative 3 divided by the rate for experiment 2, which is 1.2 times 10 to the power of negative 3, equivalent to the rate constant, and then you go ahead and copy out all the values for the concentration. Alright, so the next up is you're going to slash out all the things that are similar. So leaving u with this one, you divide, equivalent to 2. So 2 to the power of z. So z ln 2 is equivalent to ln 2. So z equivalent to ln 2 over ln 2. So z is equivalent to 1. Therefore, from our calculation, we get your x is equivalent to 2, y is equivalent to 0, and your z is equivalent to 1. So looking back at our rate is equivalent to k, concentration of A to the power of x, B to the power of y, and also C to the power of z. So k, A square, B to the power of 0, and C to the power of 1. Or you can also write it as A to the power of 2, C. Alright, so from here, what you need to do is, because you were asked to calculate what is the rate constant, so what you need to do is you can pick either one of these and just plug in the value to get the value of k. So for instance, for this example, I'm going to use experiment number 4. Right, since we are using experiment number 4, your rate is 2.4 times 10 to the power of negative 3. So the k is the one that you want to calculate. Your A is 0.2 to the power of 2, and your C is also 0.2 to the power of 1. So from here, we can have the k is actually equivalent to 2.4 times 10 to the power of negative 3 divided by 0.2 to the power of 2, 0.2 to the power of 1. So which is equivalent to 2.4 times 10 to the power of 3 divided by 8 times 10 to the power of negative 3. So you should get your rate constant is equivalent to 0.3 liters square per mole square per second. So this is the final answer for the question 3A. Alright, we have now reached the final question for your test 1. Consider the hypothetical reaction below. Forecast the rate of formation of the product when Y reacts with X at the rate of negative 15.0 times 10 to the power of negative 2 mole per liter per second to produce the product. In order for you to answer this question, the first thing that you need to do is you need to be able to write the rate expression. So rate expression is equivalent to rate equals to negative delta concentration of X over delta T equivalent to negative 1 over 2 delta concentration of Y over delta T equivalent to positive delta concentration of X, Y, 2 over delta T. In the question given to you, it states that Y react with X at the rate of negative 15.0 times 10 to the power of negative 2, and you were asked to find the rate of formation of the product. It means that in this rate expression, these two things are very important to be looked upon. So what I'm going to do now is I'm going to write again this expression so that it is easier for us to do the calculation. So delta concentration of X, Y2 over delta T is equivalent to negative 1 over 2 delta concentration of Y over delta T. Given to you in the question, delta concentration of Y over delta T is equivalent to negative 15 times 10 to the power of negative 2. So, equivalent to 1 over 2 times negative 15 times 10 to the power of negative 2. So, you shall get the rate of formation of the product is equivalent to 7.5 times 10 to the power of negative 2 molar per second. So from the question we know that you are looking into the rate of formation of product. So indeed the final answer should always be positive because the product will be positive and only the reactant in the rate expression we express it as negative. Alright guys, this is the end of this week's video. Thank you very much for watching this video, and I hope that this video may help you to understand more on how to answer all the questions from test 1. So I'll see you again next week. Take care, be safe and be good. Goodbye for now.